All right, so we're gonna go ahead and record this. I already recorded this once and the program crashed. So I'm trying it again. So I'm gonna upload both videos. So I'm gonna upload the other one for mean absolute deviation, your last bit of analyzing data. And I'll upload this one because that first one I might have touched on something better even though you could only hear me. I also posted a picture of these notes so that you could reference them, but I wanted to give you my best, so I wanted to re-record them. All right, so it's our last little bit of data displays. And it's called mean absolute deviation. Mean absolute deviation, okay? Let's try to break that apart because those are some really big words. So mean we know is average. When we absolute value something, we make it positive. Remember, absolute value is the distance from 0. So like -5 is 5 away from 0. 3 is 3 away from 0. When we absolute value a number, we're finding how far away it is from 0, and we make it positive. So absolute and then positive, absolute value is like distance from 0. So absolute positive distance. Deviation. If you deviate from the plans, that means you don't follow your plans. If you're a deviant, that means you're just never listening. You do your own thing. So deviant is like when you go away from something. So average positive distance away, and then it's from the average. Let me restate that for you. When you're finding the mean absolute deviation, you're finding on average how far away a number is from the average. So on average, the positive distance, your data, so on average, comma, it's the positive distance that your data points are away from the average, okay? So I'll give you an example. If I was to record, or if I was to, ask people how old they were when they lost their first tooth, and everyone said 5, except for one person said 4. Okay? We'd add all those together. We would divide it by how many people I asked. We would then subtract all those from the people asked, and we'd say, okay, most people are 0 away from the average. Most people, all the 5-year-olds, they were really darn close to that average. The 4-year-old was just a little away. Okay, so you're just saying how far each of your data points are from each other. It's kind of cool. So I'll give you the steps. Step 1 is you need to find the average. Oh yeah, and I forgot, guys, that in school I'd always put the steps here and then just number them. I'm relearning too. Okay, so step 1 is find average of data points. Okay. So step 2 is to then, or we call average or mean. Remember, we call them the same thing. Mathematicians like to have 2 words for the same thing because we like to confuse people. Step 2 is subtract mean from each data point. Step 3 is to find the absolute value. From step 2. Absolute value numbers from step 2. And step 4 is find the average of step 3. Okay, as always, I'm going to go through this with you because it seems kind of confusing. So let's just repeat. First, you find the average or mean of the data, which we learned how to do. So it's just when you add them all up and divide by how many. Subtraction, you know how to do that. Absolute value, you make it positive, and then find the average. So I'm gonna just like to show you how simple this can be, even though it sounds complicated. Let's take the steps you would need to do this. Finding the average means you add and then you divide. Subtraction is just subtraction. Absolute value is when you just make it positive. And then averaging is just adding and dividing. So these are all skills that you've had for a long time. So adding, dividing, subtracting, making positive, adding, dividing. So let's go back to our years of kids at the movies, okay? So our years of kids at the movies were 9, 10, 10, 11, 12, 13. Oh, there was another 12-year-old in there. 9, 10, 10, 11, 12, 12, 13. So step 1 says find the average, which we've already done this, but just as a reminder, you add them all together and divide by how many you have. Okay, when you add all these together, you get 77. And when I divide 77 by the number I have 1, 2, 3, 4, 5, 6, 7 data points. I get my average age at the movie theaters was 11. Okay. Step 2 says subtract mean from each data point. So I'm going to take each data point that we had. I'm going to subtract 11 from it. -2. Ready? 10 minus 11, -1. 10 minus 11, -1. 11 minus 11, 0. 12 minus 11, 1. 12 minus 11, 1. 13 minus 11, 2. Okay. So step 1 was to find the average. We have already done that now, but we added all the numbers. We got 77. We divided by 7 and we got 11. Step 2 says subtract your mean, which was 11, from all of your data points, which we just did. Okay. Now step 3 says to make all of them positive, to absolute value them. We learned that when you put these bars around something, it means make it positive. We learned that when you put these bars around it, it means make it positive, positive, the same for 0, the same for 1, the same for 1, the same for 2. So again, we found the average. We found that, okay, the 9-year-old was 2 away from the average. The 10-year-old was 1 away. The 10-year-old was 1 away. The 11-year-old was 0 away. It was the average. 12-year-old was 1 away. 12-year-old was 1 away. And our 13-year-old was only 2 away. So you can already start to see that our mean absolute deviation is going to be low. Most of the kids that went to the movie were pretty close in age. So on average, they were close to the average. Okay. Now, step 4, our last step, says find the average or mean from step 3. So I'm now going to take all of these numbers and average them. So 2 plus 1 plus 1 plus 0. Some people might not include 0, but you have to. It's still part of the numbers, okay? Plus 1 plus 1 plus 2. Okay? So to find the average, we add them all up. 2 plus 1 is 3, 4, 5, 6, 7, 8. And then to find the average, you divide by how many you have. And we know we have 7 data points. We've worked with this set a lot. And when you do 8 divided by 7, you're going to get 1.14 ... That means it's an irrational number. It goes on forever without repeating. So my mean absolute deviation was 1.14. That means that on average, every kid who went to the movie was 1 year away from the average person. Now we know the average person was 11. So on average, each person going was 1-ish away from the average. Now, if we look back at our data, that makes sense. This person was 1 away, this person was 1 away, this person was 1 away, this person was 1 away. This person was 2 away, which you see, oh, but on average, they were 1.14. You have to account for all of them together, account for the zeros, and account for the other 2. So you have now learned a lot about different ways to analyze data. I'm going to go through them one more time for you because you need to answer your essential question, which was how can data analysis help us? Okay. Well, your mean is the average. Okay. Averages take all the highs and lows. Think of it as like buckets of sand, and then they equal those buckets of sand. So all the buckets have the same amount. So if a one bucket had a lot of sand, one had none, what averages do is it averages out so they all have the same amount. Okay, it accounts for things. Okay, when you do your mode, your most occurring, I like to use that just as like an informal amount. So if I was to ask my friends, I use this example in the other video, how many pizza slices do you want? How many do you want? And most of them say 2. I'm gonna make sure that I order enough pizza so that most of them have 2. If I'm at a friend's house and we're listening to music and most people say that they want to listen to Lizzo, I'm going to put Lizzo on. You don't always have to account for what everyone wants. It's sometimes just a way to get a quick understanding of the data. Median is nice because it chumps off all those outliers. If you have a really high, like we have that 90-year-old back in our movies, if we just chop off and get to the middle, you're not including that 90-year-old in your average, okay? Because in an average, you have to include that 90-year-old, and it's going to make your data skewed. It's going to make your data larger than what it should be. But when you do a median and you chop off till you find the middle, you're getting rid of those really low and really high numbers that can affect your data. Okay. Your range, remember, it's the highest minus the lowest. It tells you how spread apart your data is, so you know if it's really close and clustered or if it's spread apart. Your outliers, again, your outliers tell you if you have data that's too high or too low. Your 5-number summary is nice because it gives you 5 different data points to summarize a whole set of data, because sometimes it's kind of hard to just have one data point to analyze it or to represent it. But when you have a 5-number summary, you're accounting for all, you're chunking your data into 25%. 25% of your data go from 0 to this. 25% of your data go from here to here. 25% of your data goes from here to here. And 25% of your data goes from here to here. So it lets you kind of have a better understanding, but it is a lot more work. Your IQR, which you learned, is when you take your Q3 minus your Q1. So that just tells you the middle. Again, we're chopping off those outliers and we're just looking at the middle 50% of our data. And then now your mean absolute deviation tells you how far away each of your data points are from your average. Thanks, guys. Remember, if you have any questions, please, you can use Core Focus, Khan Academy, or set up office hours with me. I'd love to see your wonderful faces.